Welcome back, chemistry students. Today we're going to talk about Dalton's law of partial pressure. When it comes to the math, I think that this is probably about the simplest law, not quite as difficult, I don't think, as either the Boyle's or Charles problems that we were doing. So Dalton's law of partial pressure says that the sum of the partial pressures of all the components in a gas mixture is equal to the total pressure of that gas mixture. Or another way of saying it is that the total is equal to the sum of the parts. So the math is pretty simple: addition, subtraction. If I want to know the total pressure, I add together the pressure of gas A plus the pressure of gas B plus gas C, however many of them there are. Important note: when you're going to add numbers together, I can't add inches and feet and get a reasonable answer. Likewise, I can't add atmospheres and millimeters and kPa and get a reasonable answer. So the pressures must all be in the same units. Here's an illustration of Dalton's law. If I had this blue gas here, and it's in a certain size container, and it was exhibiting a certain amount of pressure, and I had a second container with this orange gas here, equal volume, exerting a certain amount of pressure. If I were to transfer those two gases into the same equal volume container, the pressure that they will exert will be the sum of the pressure exerted by the blue gas and the pressure exerted by the orange gas. So the total would be the pressure of A plus the pressure of B. So you can see that the combined pressure is higher than the individual pressures. Here's an example of a problem using Dalton's law. I have a flask and it contains three gases: oxygen, argon, and carbon dioxide. And their pressures were expressed as 745 millimeters of mercury, 0.278 atmospheres, and 391 millimeters of mercury. Well, I cannot add those numbers together. I would not get a reasonable answer. So in order to determine the total pressure, in order to add them together, they must be in the same units. So I have millimeters of mercury here. I have millimeters of mercury here. I'm going to choose to take the odd man out, atmospheres, and convert it to millimeters of mercury. So theoretically, we did conversions back earlier in the chapter relating the units of millimeters, atmospheres, kPa, etc. To get this information, how many millimeters in an atmosphere, you can refer to the gas chapter reference sheet where it has the gas equivalent. 760 equals 1 equals 101.325, etc. So I'm going to start by writing down my starting value, atmospheres, put that unit on the bottom, put what I'm trying to find, millimeters of mercury, on top. The relationship is 760 millimeters of mercury per 1 atmosphere. So 0.278 times 760 gives me 211 millimeters of mercury. So as you go to do the homework problems, if the pressures are not in the same units, you must convert. Show me your conversion factor like I did here. Once I have them in the same units, I can simply add them together. 211 plus 745 plus 392 equals 1347. While I'm not being a real stickler about SIGs, we are adding, so our answer should be to the same place. I wouldn't round it to 3 sig. Here's another example. We have a mixture of hydrogen and oxygen. Now we are given the total pressure of 275 and partial pressure of hydrogen is 159. What is the partial pressure of the oxygen? Well, adding those two numbers together is not going to give me the partial pressure of the oxygen. Let's look at what I have. In this case, I have two gases. So the total is going to be the sum of pressure A and pressure B. Plug in what I know. I know the total is 275. I know that the pressure of A, or hydrogen, is 159. What is the pressure of B? Well, to solve for the pressure of B, to get pressure of B by itself, I must subtract 159 from both sides. So 275 millimeters minus 159 millimeters equals 116 millimeters of mercury for the oxygen. So when you're doing this, try to think about what the answer should look like. If I'm looking for a partial pressure, it can't be larger than the total. It has to be smaller than the total. So using these examples, this one does not appear in your notes, but you could be writing it in your notes as well. But use these examples to help you solve the homework assignment, which is Dalton's law of partial pressure problems.